All right, this is 6.4, chemical reactions. And there's only one topic in this one, how to go from a word problem to a chemical formula. Basically what we're doing is we're doing really the thing of chemistry, which is writing out and doing chemical reactions. And so I've given a couple different word problems, right? And our task here is to turn these words into a chemical formula. How do you do that? Well, let's try it. Now, with my AS students, I go through it very fast with you guys because generally you guys are good at decoding word problems and turning them into and solving a problem like that. With my regular chemistry students, I provide a little bit more support by going through them in depth and going really slowly because I know word problems are challenging. And so I'm going to go through it slowly, but AS, if you are watching this video and you want to go a little bit faster, go ahead. So yeah, let's talk through this. So here we have magnesium, and it's reacting with sodium fluoride to produce magnesium fluoride and elemental sodium. Okay, how do I translate that mess? Well, my first step whenever I do these is I first try to figure out, okay, well, what are my players? Meaning, like, okay, what are the substances that are involved here? And I'm going to underline those. And so, I see, well, magnesium's a substance, right? Sodium fluoride's a substance. I have magnesium fluoride and elemental sodium, okay? And so first, identify your players. We got 4 different players here. Now, let's try to figure out what the rest of this junk is. Well, here it says reacts with, so I'm going to box that. And reacts with, what that means, whenever you see reacts with, okay, think of a plus. So magnesium plus sodium fluoride. Now, to produce is one thing, and that means arrow. Okay, so that means arrow. So magnesium plus sodium fluoride arrows to, it yields, it produces magnesium fluoride, and is always going to be a plus as well. And so we can turn this jumbled mess into a word formula. We can turn it into magnesium plus sodium fluoride arrows to magnesium fluoride and elemental sodium. Sorry, I'm going off the page a little bit here, so my handwriting is sloppy. But so that would be a good word formula, okay? And that can be your initial step. Now, once you're at a word formula, now your the second step is to turn it into a chemical formula, and that requires us to think through. This is the stuff that we learned in Unit 4. Remember in Unit 4 what we did is we learned how to take words and turn them into equations. And so that's what we're going to do here. And so magnesium, and any element really, is going to be pretty easy because all you have to do is think, okay, well, magnesium is just an element, and you got to think through its chemical symbol. And so magnesium, its symbol is just going to be Mg. Now, sodium fluoride is an interesting one because if you think through its symbol, sodium is Na, and then fluorine is F. Now the question though is, what is it? Is it Na2F3, Na1F2? What's the combination here, right? And the way you determine the combination of Na to F depends on if this is covalent or ionic. If it's covalent, then the prefixes will tell us what it is. If it's ionic, it's going to be based on charge. Now remember, the way that you can determine, and this is, I'm going to put this on another page because it's a little bit of an aside, right? But the way that you can determine if something is covalent or ionic, right, is via metal versus non-metal. So what type of compound do we have, right? The way you determine that is, if you have a metal and a non-metal, right, that is going to always be ionic, right? Because it's the 2 extreme ends of the periodic table. One is giving, one is receiving, right? Whereas if you have 2 nonmetals, right, you have nonmetal plus nonmetal, you are going to have a covalent compound. Now remember, with covalent compounds, right, we're going to use prefixes to determine number Whereas if you have ionic compound, charges will determine the formula, right? So, yeah. So let's go here, right? And with that aside, Na, is it a metal or is it a non-metal, right? And let me run over and grab a periodic table. All right, so here with Na, we see it's over here, right? And remember, everything to the left of this staircase, all of these guys are metals. Whereas everything here to the right of the staircase, all these guys are nonmetals. And so we have Na here, and we have F here, right? We have a metal and a non-metal. Metal and non-metal. So what do we have? Right? This is going to be, therefore, ionic. So we have to use the charges. Now remember, what is the charge of Na and F if they become ions? Well, again, that's all back to unit 4. Remember, all the guys here are going to be +1. These guys are going to be +2. These guys are going to be +3. And these guys are going to be +4 / -4, but not really. They're going to be sharing more so. Okay, so don't worry about these guys. These guys are going to be -3, -2, and -1. And remember, this is based on the number of valence electrons they have, right? This has 1, so it's going to lose 1. This has 2, it's going to lose 2. This has 3, so it's going to lose 3. This has 5, so it's going to gain 3. This has 2, so it's going to gain 2. This has 1, so it's going to gain 1. Sorry. This has 5, so it's going to gain 3. This has 6, so it's going to gain 2. This has 7, so it's going to gain 1, right? And so that's how we determine it. So here, Na is +1, F is -1. Do practice that if you forgot, right? But since Na is +1 and F is -1, it's fine like that, right? And so it's 1 to 1. We only need 1 of each. And so we're just going to have NaF. Now, magnesium fluoride, we're going to do the same thing, right? I'm going to take a look at the periodic table. Magnesium is here, fluorine is here, metal, non-metal. Now, do note, though, Mg is going to be a +2 because it has 2 electrons, valence electrons. You're going to want to lose those 2, so it's going to be +2. Fluorine is -1, right? And so you're going to need 2 of these guys, 2 -1s, to be overall -2. Right? And here, if you have just this Mg, it'll be +2, they're going to cancel like that. And so you're going to need MgF2. And then sodium, elemental sodium, that just means sodium by itself. Right? And so this is your formula. This is your equation. And so a lot of work, right? But you see how we can go step by step, right? First to a word formula, then you can go from a chemical formula based on if it's metal, non-metal, ionic or covalent, right? And so that's how you do this first one. Now, the second one, fluorine reacts with aluminum bromide to produce bromine and aluminum fluoride. Again, we can first go to a word formula. First, kind of break it down. We got fluorine reacts with aluminum bromide to produce bromine and aluminum fluoride. Those are our little our players. Then reacts with, right, that means plus to produce. There's an arrow, and it's a plus. So now we got fluorine plus aluminum bromide, arrows to bromine plus aluminum fluoride. Right, and so that's our word formula. Now to turn into a chemical formula. What you're going to do is you're going to turn each of these into its symbols, right? And so fluorine turn into F. Now, one thing though to note with fluorine, it's actually going to be F2, which I'll explain in a second. So it's F2, and then aluminum bromide, aluminum metal, right? It's on this side. bromine nonmetal, so AlBr. Those are, it's ionic, right? Metal nonmetal. And so Al has a +3, Br has a -1. You're gonna need 3 of these for every one Al. So it's gonna be AlBr3. Produces bromine, and bromine's also Br2, and then plus aluminum fluoride. And so Al, we have Al and F, again, take a look, and Al metal, F non-metal, it's ionic, so we use the charges. Al +3, F -1, you're gonna need 3 fluorines for every 1 aluminum, right? And so that's our formula. Now, why the heck did I put F2 and Br2 rather than just F and Br? Well, these are part of our, what we say, diatomic elements. Now, if you guys remember, in Unit 4, I did talk to you guys a little bit about, for example, we only ever see oxygen as O2. You never write just oxygen. Fluorine, actually, also, you never see it as just fluorine. You always write F2. The reason for that is because these elements are going to be extremely unstable unless they're with something else. And they're also always found as gases, and these gases are always found together. And so there are these 7 or so. But the good thing is they're really easy to remember. Basically, it's these guys. It's this little L of the periodic table. So these guys, as well as hydrogen, are all going to be diatomic. So H, N, O, F, Cl, Br, and I. These are all going to be diatomic. And so here, when we have F and Br, those are diatomics. And so, yeah, we're going to put a 2 there. And so that's why that happened. Now, phosphorus and oxygen react to form diphosphorus pentoxide. Let's also do this one. Word formula, right? What we're going to get is phosphorus, oxygen, phosphorus pentoxide. The and is always going to be plus. React to form is going to be an arrow. You're going to have phosphorus plus oxygen, arrow 2, diphosphorus pentoxide. So you go from word to chemical. Now phosphorus is not diatomic, right? So you can just put P. Oxygen, though, do note it is diatomic, so you put O2. And then diphosphorus pentoxide, P and O. Now do note, right? There are prefixes there, right? And so that by itself tells you that it's that it's covalent, right? But if you wanted to check, right? P and O, right? These are both nonmetals, right? They're on this side of the staircase, right? So they're both nonmetals, and so yeah, we're going to use the prefixes because they're covalent, right? 2 nonmetals, covalent, use prefixes. And so here, di, remember, is 2, oxide is 5, and so here is your formula. P plus O2 yields P2O5. Wonderful. And then lastly, let's do this one. Calcium carbonate decomposes into, well, actually, let's figure out our players first. Now, decomposes into, that's also just an arrow, and it's a plus. And so now we can take it, turn it into a word formula. So calcium carbonate plus, or sorry, yields, right? Because that's our next thing. The arrow, calcium oxide, and carbon dioxide. And so now we have our word formula. Let's turn it into a chemical formula. We can do that by taking a look at this guy, Ca. Plus 2, and then carbonate. Now, for my regular chem students, I'm going to give you guys these so you don't have to memorize. But for my AS students, there are those 6 that you have to have memorized, right? And so these are what we call polyatomic ions. there's 6 of them that, well, at least I think you should have memorized. There's like a list of like 20 or so, or 50 or so, especially that you 20 or so that you need to know for AP chemistry, especially. But again, for me, I'm okay with 6 because you can scale up and down depending on future science courses that you take. But those are carbonate, which is CO3 minus 2, phosphate, which is PO4 minus 3, sulfate, which is SO4 minus 2, nitrate, which is NO3 minus 1, chlorite, which is ClO2 minus 1, and lastly, we have hydroxide, which is OH minus 1. These, I think, are especially important for you guys to have exposure to, even for regular chemistry students, because these actually come up in a lot of different places. So, for example, sulfate. Take a look at the back of any shampoo or any sort of detergent or soap that you use. It's gonna have something called sodium lauryl sulfate. Most things that you clean with have sodium lauryl sulfate, and so it's a kind of common everyday thing. So when you see sulfate, you won't wonder, wait, what is that? You'll know, oh, that's a polyatomic ion. Nitrate is another important one, because if you take environmental science or even in biology, actually you saw this and you probably didn't know what it was, and the biology teachers don't go hard on it because they know you haven't learned chemistry yet, but environmental science, AP environmental science, AP bio, all have the nitrogen cycle, and there's nitrate in there. Carbonate, kind of similar thing, very important for the carbon cycle. If you're going to take any, it'll be helpphul for those courses. Phosphate, extremely important in biology, again. Do you guys remember adenosine diphosphate, ADP, and adenosine triphosphate, ATP? That's what that is. And then chlorite, just practically, if you ever use bleach, that's hypochloric acid, I think. There's chloride ions in there. That's really what's doing the cleaning and bleaching. And then hydroxide, I think this is in... is it baking soda? Sodium hydroxide. So yeah, this one also is in a lot of common household everyday items. So yeah, you'll see these around all the time, which is why I think it's important to know these. But so anyways, point is carbonate, that's CO3 minus 2. And so if you ever see a polyatomic ion, of course, it's going to be on an ionic compound. That's why I knew calcium, I started putting the +2 because I knew this was going to be polyatomic because of I knew this was going to be ionic because of the polyatomic ion. And so Ca +2, CO3 minus 2. Do note this minus 2 is for everything in here. And so it's overall -2 charge for everything in here. +2, -2. You're fine just putting it like that. Calcium oxide, you have Ca +2, O minus 2. And so, this is CaO plus carbon dioxide. That actually is a covalent compound. And so I'm going to put CO2. And so, yeah, there you go. That's the formula there for the equation. And so there you have it. That's how you go from word problems to chemical formula. Hope that helped. Let me know if you have any questions.